All right, now, Kendall brought this up as we were answering a question today. She mentioned, Haley, it's not time for the pencil sharpener. We should know that by now.
Pretty sure you told us that.
Kendall mentioned the ozone layer. So the ozone layer is a layer of gas, O3 gas, very high in the atmosphere. And it has an important job for us. Actually, ozone, remember we talked about a gas that's bad for our lungs, found at ground level when sunlight reacts with pollution? What did we call that? Smog. And smog is really ozone, but at ground level. So ground level, ozone, very bad for us, bad for our lungs. But ozone way up high in the stratosphere is very good for the Earth, and it's necessary, because it does something important. Nick, do you know what it does?
Yeah, it protects like stuff from the atmosphere compared to almost like carbon and
Sort of, you're on the right track, I think. It does prevent something from reaching the Earth. Tatum? Yeah, you're real close. So not all sunlight. It doesn't block, it allows the visible light through, but it does block one part of the sun's energy. What rays? What? UV rays. Ultraviolet rays are part of the radiation that comes from the sun, reaches the Earth's atmosphere. And UV radiation, you know, if you buy sunglasses, it'll say they block UV rays. What else do you use to block UV rays? Sunscreen. Because UV rays have an impact on our cells. Now, the things we think of, they give you a suntan. Your skin produces more pigments when it's exposed to ultraviolet radiation, giving you a tan. However, if you're exposed to too much ultraviolet radiation, what's the next step beyond a tan? Well, before we get there, a sunburn. Right? We all had a sunburn probably before. And a sunburn is damage to your skin cells. But this ultraviolet radiation can also damage our DNA. And the more we're exposed to ultraviolet radiation, the greater our chances of developing skin cancer. Skin cancer, and all types of cancer, are caused when our cells change. And the controls over cell division are interfered with, and the cells start dividing sort of uncontrollably, forming tumors. That's what cancer is. And ultraviolet radiation can sort of encourage our cells to start to do that. So the more you're exposed to UV radiation, the higher your risk of skin cancer and other types of eye cancer as well. It's also bad for all organisms. It's bad for plankton in the sea. They can be damaged. They can be killed. So this layer of ozone gas high in the atmosphere filters out some of that ultraviolet radiation, so not as much gets to us. Okay, so let's fill in some things. So the ozone layer blocks UV radiation. That's what it does high in the atmosphere. And the problem is that there are these chemicals called chlorofluorocarbons. We abbreviate that CFCs. And these chemicals, when they're used and produced by humans, and when they are released and get up into the atmosphere, they actually start to destroy the ozone layer. And these CFCs, they used to be quite common and in lots of things that you use all the time. Spray paint, hairspray, shaving cream. In aerosol cans, you know what an aerosol can is?
Yeah.
Cleaners. Inside of an aerosol can, there's like the product, like the hairspray or the paint or the desk cleaner. And then there's what's called the propellant that sort of pushes out the product. The propellant used to be made out of CFCs. So you're getting ready for school in the morning, putting on your hairspray, and the hairspray is going in your hair, and then the CFCs are going up in the atmosphere. Work their way up into the stratosphere and start breaking down the ozone layer. And it became thinner and thinner, eventually developing holes in some areas. What that means is there's more ultraviolet radiation getting to the Earth because this ozone layer is thinner, because there's a hole in certain areas. And more ultraviolet radiation reaching the Earth leads to those health problems we were just talking about. This satellite image or interpretation shows 1979. This is over the South Pole, Antarctica. And you see the bluish areas are thinning of the ozone layer. This is 2008. It shows a much greater degree of thinning of the ozone layer. Okay. Their hole was over Antarctica. Now there is good news about this though. So in 1987, representatives from various countries throughout the world met in Montreal and came up with an agreement. They called it the Montreal Protocol, and it was an agreement to limit the use of CFCs in products. So nowadays, if you use a can of hairspray, the propellant is not made with CFCs anymore. It's another chemical that doesn't harm the ozone layer. And so they limited the use of CFCs in various products. They're still used in certain things like refrigeration units, air conditioning. Car air conditioner has Freon in it, that's a CFC. But they're much less frequently used now. And since then, scientists study the ozone layer and keep track of its thickness and so forth. That's what this video we'll watch is about. But they've seen that the level of CFCs increase while we're using them, but has since stabilized and is even starting to decline somewhat. And the destruction of the ozone layer has diminished, and actually, in certain parts, is starting to regenerate somewhat. So things can be done about these problems. We improve the situation with acid rain as well by releasing less sulfur, using cleaner fuels with less sulfur and nitrogen. Okay, we can do things about smog, like emissions controls. We did things about CFC. So these problems can be addressed. But most of them take large-scale efforts. Many countries working together, agreeing to do certain things to meet certain goals in terms of the environment. One state can't do it on its own, but one city, one country even, because these are global problems. They affect the entire Earth. And therefore, they take cooperation from many different governments, and sometimes that's a challenge. All right, any questions about the ozone depletion, the ozone layer? I'm going to show you this little video. It's from NASA. It's pretty neat. It shows you sort of the satellite that they're using to monitor ozone levels, and talks a little bit about ozone depletion and the history of the issue.
Don't let this happen to your planet. Presented by Science at NASA. Ozone stinks. People who breathe it gag as their lungs burn. The EPA classifies ground-level ozone as air pollution. Yet without it, life on Earth would be impossible. A fragile layer of ozone 25 kilometers above Earth's surface is all that stands between us and some of the harshest UV rays from the sun. The ozone molecule O3 blocks radiation, which would otherwise burn skin and cause cancer. On Mars, which has no ozone layer to protect it, solar UV rays strafe the surface with deadly effect, leaving the apparently lifeless planet without the simplest of organic molecules in the upper millimeters of exposed Martian soil. To keep track of our planet's ozone layer, NASA is about to launch the most sophisticated space-based ozone sensor ever, Stage 3, slated for installation on the International Space Station in 2014. The ISS is the perfect orbit for Stage 3, says Joe Zawodny, project scientist for the instrument at the Langley Research Center. It will be able to monitor ozone all around the Earth during all seasons of the year. Stage 3 works by using the sun and moon as light sources. When either one rises or sets behind the edge of the Earth, Stage 3 analyzes the light that passes through Earth's atmosphere. Ozone and other molecules absorb specific wavelengths that reveal their density, temperature, and location. Stage 3 is essentially analyzing the colors of the sunset to track ozone, says Zawodny. It sounds romantic, but this is hard science. Researchers began to worry about ozone in the early 1970s, when University of California chemists Sherry Rowland and Mario Molina testified before Congress that man-made CFCs, a key ingredient of common aerosol sprays, could destroy ozone in the stratosphere. In 1985, researchers with the British Antarctic Survey announced abnormally low ozone concentrations above Halley Bay near the South Pole. Our planet had an ozone hole, and it was rapidly growing. In a remarkable display of international cooperation, an ozone treaty was negotiated only 2 years later. The Montreal Protocol regulates the production of CFCs and other ozone-destroying chemicals. First signed in September 1987, it has since been ratified by every member of the United Nations. Because of this agreement, ozone is now on the mend. Ozone holes still open every year above the South Pole, but thanks to the treaty, ozone-destroying chemicals have either leveled off or decreased. At this rate, the ozone layer could recover almost fully by 2050. To ensure that ozone really is recovering, NASA has been flying ozone sensors in Earth orbit for decades. The first of the SAGE sensors rode to space on Earth-observing satellites in the late 1970s and early 80s. SAGE-2 data helped confirm the decline of the ozone layer and measure the effect of the Mount Pinatubo eruption on the stratosphere. A SAGE sensor on board the Russian Meteor 3M satellite extended the ozone record into the 2000s with higher precision than ever. Zawodny is eager to learn what SAGE-3 finds in the lower stratosphere over the tropics. The recovery of ozone there is tied to changes in greenhouse gases like CO2. Given what we know about recent increases in greenhouse emissions, it is possible that ozone in the tropics will never return to 1980s levels. SAGE-3 probes Arctic regions too. Using the moon as a light source, SAGE-3 can detect ozone during the darkness of polar winter where other satellites have trouble seeing. It's enough to make a hard-nosed researcher wax eloquent. Images of the moon and sun rising and setting are dramatic and spectacular. The interplay between the source of light and the environment delights the senses and stirs the imagination. The ability for SAGE-3 to turn those perceptions into something meaningful is a great pleasure.
All right, so you see there a little bit about the monitoring of that ozone and a little bit about the history of it. So let's move on to our final environmental issue, which is climate change. So your slide looks a little bit different. Yeah, climate change is really a better term for this issue. The one in your notes says global warming. They really refer to the same thing, although climate change is more accurate because this issue is not just related to the temperature of the Earth changing. There's much more to it than that. Changes in moisture, changes in humidity, changes in weather patterns, and ocean acidity, and things like that are also important here. But climate change, global warming, the terms are sometimes used interchangeably. So global warming or climate change is sort of what it sounds like. The average temperature of the Earth is increasing. It's getting warmer year after year. And it's caused by something we call the greenhouse effect.
Does this go under politics?
Yes. Has anyone been in a greenhouse on a sunny day? What's it like in a greenhouse on a sunny day, Gavin?
It's like blazing.
It gets really hot. It's kind of like when you're in your car, you know, your parents go in the grocery store, they leave you in the car. Hopefully they don't roll up the windows and lock the doors on a sunny day. Because what happens? It gets really hot. Because sunlight comes into the car or the greenhouse, but heat can't escape because it's enclosed. So the windows allow light in, but heat cannot escape, and temperature builds quickly. There are gases in the atmosphere that basically do the same sort of thing with the Earth. They allow sunlight through, but then they trap the heat close to the Earth's surface, keeping it warm. What is the main greenhouse gas that humans are producing and releasing? CO2, carbon dioxide, correct. Carbon dioxide levels in our atmosphere are increasing. We can monitor them. We can even go back and find out what the carbon dioxide levels are hundreds of thousands of years ago, even though there were no people to record that, because we can look in ice cores and take little bubbles of air and analyze that. We know when they were formed, and we can look at it. So carbon dioxide is accumulating in the atmosphere. Why? What are we doing that's releasing carbon dioxide into the atmosphere? It's not our breathing. People often say because they know we exhale carbon dioxide, but that's not really a major contributor. Nick?
Resources,
Such as what?
like fossil fuels.
Especially fossil fuels. We are burning large amounts of fossil fuels. And the burning of fossil fuels releases large amounts of carbon dioxide. And so if we look at graphs showing carbon dioxide levels over the last hundreds of thousands of years, what we'll see, and I'll show you this graph in a minute, is a huge spike in the last couple hundred years. Why? Why in the last couple hundred years? Let's make a link to our social studies that you've been studying. James?
Because from the last few hundred years, the Industrial Revolution was, and now we're starting to build bigger and better materials and more factories now to build those things, and it takes a lot more energy to do them.
Yeah, James gave us the exact word I was looking for. Carbon dioxide levels increased drastically since the 1850s due to the Industrial Revolution. So what happened? So remind me from your social studies this year. What happened during the Industrial Revolution? What does that term mean? I want to hear from a new participant here that hasn't talked yet. Not Mr. Farrow, somebody other than Mr. Farrow. Matt, you had your hand up briefly. What was the Industrial Revolution?
It's like there's a time when like man-made tools were replaced by factories, like machines.
Yeah. It's when the economies started to switch from like manual labor of humans doing things to using factories and machinery. But those factories and machinery, what does it require? Energy. Where'd that energy come from?
Fossil fuels.
Fossil fuels, especially coal. And so the Industrial Revolution is where our consumption and use of fossil fuels really started to take off. And burning those fossil fuels releases the carbon dioxide. Okay, so we're releasing lots of carbon dioxide. It's trapping heat. The Earth's surface. The Earth is getting warmer. So what? Most of us like when it's warmer out versus when it's colder out. So why do we really care about this that much? Why am I saying it's probably the biggest issue that's going to face you guys as you get older? What are the consequences of the Earth becoming warmer? James?
Because the Earth is becoming warmer, and the ozone layer is having holes being drawn into it, the UV rays are going to eventually penetrate the ozone layer, and that's going to hurt our economy and our way of life and our food supply.
Okay. So you're sort of like doing kind of what Kendall did earlier, is we have ozone depletion and global warming. Let's sort of separate those in our minds, because they're not that related for our purposes. So the hole in the ozone layer doesn't have any effect on global warming. That's what we're going to say. And global warming doesn't have an effect on the ozone layer. So we're just talking about global warming. Tatum?
We can make the world warmer, and then animals and humans and birds might become more scarce. We're not really eating all the time.
Okay, so I took it a few steps further there, but yeah, so as the Earth becomes warmer, ecosystems change, right? As the Earth becomes warmer, the climate changes. Well, animals and plants and organisms that live in certain areas are adapted to those specific conditions. If conditions change, if the climate change, they may not be adapted, and they may no longer be able to survive in those new conditions. And that could lead to the loss of certain organisms and habitats. What about ocean levels? Does anybody have any ideas about the level of the ocean, sea level? Kendall?
Sea levels are rising.
Why?
I know they are.
I know, but why? Why would they be rising as Earth
Messing
gets
up
warmer?
climate change.
Yes? You know the connection? No, Tatum?
When the Earth gets warmer, the sea like rises, and then it's gonna blood suck.
It does. So as you heat up anything, it expands, and therefore the oceans expand and get higher a little bit. Also, as the Earth gets warmer, ice that's lying over land in Antarctica, in Greenland, melts, and that water goes into the oceans, and that leads to sea level rising. The warmer the ocean is, the more intense storms we can have. Hurricanes and tropical storms. The energy that powers those huge destructive storms comes from in the oceans. The warmer the ocean, the more intense those storms can be. Habitat changes we just talked about. The ocean also can become more acidic because carbon dioxide forms an acid when it mixes with water. As the atmosphere becomes more acidic, ocean life can be harmed. Coral reefs can be damaged, and we're seeing that. All right, so we'll talk a little bit more tomorrow about some of these changes in sea level and other effects of global warming, and then we'll start to watch some of the video I wanted to show you.